This meeting is being recorded.
In this next section, you're going to be introduced to what's referred to as a bond line structure. And we've looked at Lewis structures, reviewed Lewis structures for a little less complicated molecules and compounds. But as we can see down here, this compound, amoxicillin, it can get a little crowded, a little busy, a little confusing when we try to draw every individual atom and every lone pair. So what is commonly used is a simplification method. These bond line structures, as noted here, are drawn in place of Lewis structures. So we really don't gain, much more from showing all the lone pairs and drawing out every single hydrogen atom because they are inferred or they're recognized, within the different functional groups and within the different lines that are shown here. So, for example, we have this ring here, which we'll learn is a benzene ring, right? And actually, more specifically, it looks like a phenol, right? Because we have this alcohol attached to our alternating single and double bonds of a six-membered ring. So these dots here on the corners are representing carbon atoms in this circle of alternating double and single bonds. So we do also show double and triple bonds, in addition to any atoms that are part of functional groups. So the hydrogen is shown here on this OH group, like they're shown here on amine groups or amides. We have oxygens are shown within carbonyls or lactones. Let's see here. What do we have? Carboxylic acid functional groups. So these are just some, right, that are in amoxicillin. So we have all these different functional groups that are shown in all the heteroatoms, but we don't show hydrogens. So you have to infer or know that every carbon will have a full octet, so it'll have 4 bonds. So there's a hydrogen inferred in these areas here because of that. So we know that carbon only has 3 other bonds, so there must be a hydrogen here. So as long as you know the rules of the Lewis structure, you know where lone pairs are and you know where hydrogens are in these bond line structures. So this breaks down how if you were given a name of a molecule and say you wanted to draw it. So we draw these linear carbon chains as zigzags, right? So the zigzag format is followed, and as I mentioned, every vertex, every corner or endpoint indicates a carbon atom. So this first molecule here, just these zigzag lines, would give us 1, 2, 3, 4, 5, 6. So this would be hexane, right? And we'll learn in a later chapter how I know that 6 carbons means hexane, right? And then we have some other structures here, but again, every corner, every dot at the end that I'm placing here is a carbon atom, but we do show those double and triple bonds for our alkenes and alkynes here. So we show 2 lines for double, 3 lines for triple bonds. So as I mentioned previously, these hydrogen atoms that are bonded to carbon are implied, they're implicit. So let's take a look here. So this dot here, right, would correspond with this spot here. So we know that carbon atom, where that dot is, only has, one other bond here. So 1, 2, 3 are not shown. Those would be to these hydrogens over here. And like so, we would fill in, the spot with only 2 bonds with 2 other hydrogens. This spot also would have 2, and then over here, 3, just like we see over here in red. So again, we would make sure that every carbon atom achieves an octet by generally 4 bonds. Uh, and then oxygens would tend to fill their octet with 2 bonds and 2 lone pairs to be neutral. And we'll get to recognize when formal charges would be found within our bond line structures. So that's everything for section 1.6. We will pick up with section 1.7 next time.